Hello, everyone. So today we'll be talking about the week 2 content. Uh, Pretty much just going to be talking about the intermediate scripting stuff, just reviewing a few of the more advanced features of scripting that you might need a little bit of a refresher on. And then later in the week, we'll be covering the state machine, get that actually working with the nav agent for the end of this week. So for these intermediate topics, just pop open this. A few of the things we'll be going over today are inheritance, polymorphism, going to skip the member hiding, overriding, interfaces, and namespaces. So as you can see, 8 and 11 are optional and not really needed for a gameplay scripting. But I do recommend that you do check out each one of these kind of Unity Learn websites and just how that can work, just so you see it from a different view. I'll be demonstrating something different in class today. So we'll start off with some inheritance. Well, inheritance, polymorphism, and overriding kind of all tie together, but we'll be seeing how to use each one of those features. So in here, I have the project that we built last week to get a nav agent just kind of moving around. One thing I'm going to do is create a quick player so that we can have control of our character actually moving around, and we'll be using inheritance on some pickups and stuff that we can place throughout the level and see how that works. So for my player, we'll go ahead and create one. I'll create just a capsule for it. We'll rename it to player before I forget and leave it just capsule. And we'll need a script controlling this player. So right click in our assets, create a C# script. Just call it player, why not? All right, so I want this moving based off of just WASDA, and I want it to move around the level. So there's a component that you probably haven't used much, and it's actually called character controller. And why is my package manager console open? I don't care about that. I just care about output and error list. Sorry. So if we know that this script is going to use a specific component, one thing we can use before the actual class is a keyword called requires component or require component. So require component makes sure that this script, when it's attached to an object, if it doesn't have that component, it'll add it for it. Comes in super handy, especially when you're got a lot of people making different things. You can add this to any script, just like our MPC script is requiring the nav mesh agent component. I could have probably added it there. We'll do this for our character controller component. For this, we'll do type of, and that's all lowercase, isn't it? Type of lowercase character controller. Character controller easily allows you to do movement constrained by collisions without having to deal with a rigid body. Sounds fantastic. So we'll go ahead and throw that on there. And what that does, we'll actually take a look at this. The script is empty other than it requires this component. So in Unity, our player right now was just a capsule that we created and renamed. If we go and attach this player script to it, it'll add a character controller by default. Character controller, very similar to the nav mesh agent component, where we have how steep of a slope can it go up, how high of a step can it go up, things like that, and have all that adjustment right here. all built in for us. So I still need to do the inputs in the script and tell our character controller to move our character. Can you use that to require a script? Yeah, certainly. If we wanted to require a component, let's say I'm curious if we can just do multiple of these. M1, okay. So it looks like I can add a comment or comma here and do another one if we wanted to require our NPC script on this as well. Let's see if we can do that. And it only adds the component if you're adding that script. So let's see if we add this script here. Come on. Ah, dang you, Unity. No, don't expand that. If we drop our player script right on our player here, it will add other scripts as well. So if you are referencing another script, might as well add that requires in there. I don't necessarily need that, and it won't even let me remove it because my player script says it needs it. So that was just for demo purposes. Get rid of that. Control S. And make sure my player doesn't have an NPC script. Be a little bit weird if our player character was a non-player character. But we've got that player script attached. It does have a character controller. And just like our nav mesh agent or our NPC script, we're going to grab a reference to it right in the start to the actual component. This will be of type character controller. Just call it CC. And initialize it to null. Then in start, let's say CC is equal to getting the component from our game object, that character controller that it added. All right. Now in update is where we can do any of our inputs and tell our character controller to actually start moving around. So a couple of things I want. I'm going to actually create a variable to track which direction we should be moving. I initialize it to null. Just out of habit, any variables you create, you should initialize it to something. If we don't have that, that is initializing it to null already. So just out of habit, I say explicitly, yes, I know this will be null. So just common code practice to always initialize any variables you create. And even if it is going to be the default value, just explicitly state it there so the compiler itself, as well as Unity, knows, yes, I know this will be null until I actually assign it inside the start function. All right. So I will be creating a variable to track which direction I want my character to move, since we're going to be using WASDA to move our character around. I'm going to create a vector and could do a vector 2. I will just make it a vector 3 since we're working in 3D space. And I'll call it move, or let's call it dir for direction. And once again, just going to initialize it to a 0 vector. Then in update, I'm going to change my dir based on those inputs. So since I want it to use axis inputs, there's a few axes already set up for us to use in Unity. If we hop over here, we can go to Edit, project settings, if we look under input manager, axes, there's a horizontal axis, A and D, or left and right arrows. And vertical are W and S for going up and down, or even the up and down arrows. So we'll be using that vertical and horizontal axis. So we'll be asking our input at get axis, and we have to type an axis name. Let's go with vertical first. Let's get our forward and backward movement working. Vertical. And I'm going to set my direction equal to this vertical axis. Direction is this, but this returns a float. And right now we can't say dir is directly equal to this float. You can't convert a float to a vector 3. So I'm going to say when I press W, I want to move in my character's forward direction. So I'll multiply whatever value that axis is returning. It's going to be 1 if I'm holding W, -1 if I'm holding S, times our forward vector. All right. And then let's just tell our character component, or character controller, CC, to do a simple move. Move takes in a vector 3, which has also got speed inside of it. So I want my direction also scaled by whatever speed we want. So I could go ahead and create another variable for the speed, float speed, and we'll say it's 5 units a second equals, so multiplied by our speed. Semicolon. Save that. Hop over to Unity. Press play. And pressing S will make our character move back. W will make our character move forward. Let's get the left and right axis working for A and D. So if we already have a direction that's based off our forward, we want to take that direction and add on to what it already is. So plus equals the horizontal axis times our right vector. Oh, darn you. Transform.right. All right. So we'll save that. And now we have 8 directional movement. And our character is actually limited by the character control. It can only go up 45-degree angle slopes and stuff, and can't quite make it up. I'm holding S, but it's not quite getting any further up that mountaintop here. So just a nice, quick, and easy way to have a controllable character. And now we'll get into the actual topics. So let's go ahead and create a, a basic pickup. We'll go ahead and use a game object. We'll just do a simple sphere. And we already have some spheres in here. I'm going to just turn off, well, I'll leave the nav points there. Instead of spheres, we'll use cubes, just so they can easily be seen apart. Cube. There we go. We'll rename it. We'll just call it pickup. And we'll create a script that we'll be using as our basic pickup script. Create C# script. We'll even call it pickup base. And basically, I want this script to just process some basic collision messages, only check if our player is actually hitting it, so it ignores our NPCs, and then actually run some code based on that pickup. So we'll go ahead and create our onTriggerEnter. And we'll want to make sure that it is checking if the other object has a specific component. In this case, we're looking for player. If it does have that component, then we'll have it call a custom function. We'll create a new function. We'll say it's a void return type, and we'll just call it doPickup. We'll also pass in the player reference just to test some things out. So we'll take in a player called P. And for our base pickup, we'll just have it print or debug log. Debug log. Base pickup run. And we'll also have the pickup destroy itself. Destroy our the entire game object. We want to make sure that our onTriggerEnter, and I forgot quotes around this. So thought it was a variable, but definitely meant to make that a literal string. Our onTriggerEnter, if it detects the other thing that's hitting us, has that component of player, we'll go ahead and call our doPickup and pass it that other get component for player. All right. So let's make sure that this is working. In our game, we'll make sure that we apply pickup base script to the pickup. We want to make sure that the collider is set as a trigger. That's important. So we'll try and play and we'll run into this pickup. Run into it, it disappears. Let's see what happens if we put it in the path of our NPC here. And we press play. NPC just walked through it, and it should get completely ignored. So definitely going straight through it. But if our player runs into it, player picks up our pickup. So we've got a base class. Now let's say we wanted to make another pickup, but a little bit more advanced. Well, let's start off with a new script. We'll call it pickup. Let's go with puppies. And for this, creates just a basic C# script that you've seen hundreds of times, hopefully by now, for Unity. I don't need any starter update, but instead of just inheriting from mono behavior, I want to change that. I want pickup puppies to be based off of pickup base, or inherit everything pickup base has. So I'm going to say pickup base here. So now pickup puppies inherits pickup base is a Unity script because pickup base inherits from mono behavior. And mono behavior inherits from component, things like that, which is how we get our scripting stuff. So keep that in mind. Any children you make, they are actually technically the same type as the parent, same type as the parent's parent, things like that. But our base pickup is not our child pickup of puppies. The reason why I created one called puppies is because I want this to do something a little bit more interesting than just saying base pickup collected and then destroy itself. When we pick up the puppies, let's give our character a little bit of a speed boost and print out a nice message. So if I want to change what happens when we're calling do pickup, there's a keyword I can use called override. If we use the override keyword and look at what we can override by default, we have equals get hash code and toString. Not a whole lot given to us by default. I want to change what happens when we call this do pickup. In order to do that, our parent class has to use a paired keyword. So just like we use virtual override in our child, we have to use the keyword virtual in our parent. We also have a problem though, because virtual or abstract members cannot be private. So by default, everything inside a class is private. We're going to need to change this protection level to allow our child access to that function. So there's a couple of different protection levels. You're probably familiar with public and private. There's another one called protected. Protected is one step higher than public, but one step lower than private. So it allows actual children access to these functions, but not every script in the game. So our player definitely couldn't access any of that, but it does give us access in our child. Now that we have that, I'm going to save our pickup base as virtual protected. We press Control Space to bring up IntelliSense. We see do pickup is now an option to override. So we'll let that autofill. And on line 9, we see it added a base do pickup. So that's actually going to call the parent function. When you let autofill do it, it kind of expects you just to want to add additional functionality on top of what the parent is doing. So we could go ahead and add whatever we want and then still let the parent run, which is going to destroy it. Or if we truthfully wanted to override completely, we could just get rid of the parent call. We'll take a look at that in a moment, but for right now, I just want my pickup, when we call pickup puppies, do pickup, we're going to tell our player to increase its speed. So I will need to make sure that speed can be modified outside of this class. Make make that public. And for our pickup puppies, we'll ask our player for its speed. And we'll say times equals 2. Double the speed. And we'll also debug.log playing with puppies gave you more energy. All right. So keep in mind how simple this script is. There's nothing about checking checking for any collision or anything like that, or what it's colliding with. It's just one function changed from our parent. We're overriding what the parent's doing. So our pickup, we'll duplicate this. And we'll move this one over here. Rename it to puppies. And we'll also make sure that rather than pickup base, well, oh, didn't mean to double click. We'll remove that and put our puppies pickup script on it. If we press play and we run into this, of course, I do not have messages showing, but we got on trigger enters happening for the other character. But playing with puppies gave you more energy as well as base pickup run. We haven't hit the base pickup one yet. But if we look at this call stack, we see it's from pickup base on trigger enter, but it's from our do pickup from our pickup puppies. So we can actually see it's calling that base do pickup right here. That's where it's actually running from. And how we actually got there was from our pickup base calling do pickup. But we don't even have pickup base attached to this object. So keep in mind, any class you're creating that's a child is also a parent. So that's where it's getting the do pickup. We did actually modify the speed, which I didn't even check out. Our character's significantly faster now. And we hit that base pickup, that's still just the normal base pickup that just disappears. We now have the ability to create a bunch of other pickups that are very simple, don't have to worry about any type checking or anything like that, and can have their own code. Let's add maybe a negative pickup. Let's go C# script, pickup. I use this one too often, but mosquitoes. Mosquitoes. So pick up mosquitoes, get rid of start and update, tell it that it is a child of base pickup, or I named it pickup base. And we'll override what happens when we hit the mosquito pickup. Mosquitoes are annoying and never go away, so we'll get rid of that parent call so it doesn't delete itself. We will make the player, when we hit it, we'll make the speed times equals 0.5f. So you go half as slow when you hit the mosquitoes because they're literally sucking the life out of you. Debug.log. mosquitoes have drained you well. Sad face. All right. Well, let's drop another object in here. Let's even use let's do a capsule and define like an area of this to affect. Say mosquitoes taking out that area over here. All right. Also make sure that it is set as a trigger. Drop our mosquito script on here. Press play. And if we hit that, we're now going half as slow. Play with the puppies, back up to normal. But our mosquitoes, because we got rid of that parent call or the base dot do pickup, they're going to stick around rather than just do what the default pickup does and destroy itself after it's been picked up. So that's the gist of how override and virtual work with inheritance. And same goes for if I was to add let's say all of our pickups have a string for the name. And let's make that string, let's make it public. Why not? String pickup name. Yes, yes. So as I was hitting the mosquitoes more, it would continuously half my speed. Sorry, it took a moment to read that. But yeah, like I was able to hit it multiple times as like an AoE instead of just a single hit. But let's say pickup name is base pickup. And then in our do pickup, rather than logging out base pickup run, we'll just go ahead and log our pickup name. Then in each of the children, we can go ahead and initialize that variable. We could say our start functions. Let's change what the name is for each one. Oh, and I called it pickup name. Lowercase p, capital N, of course. Puppies. And mosquitoes, we'll also make sure it sets its name on start. Name. Oh, I keep forgetting. Pickup name. And this is mosquitoes. So we'll Control S to save, make sure my puppies are saved. Always saving puppies. All right. So now our console. I'm gonna disable this OTE happened just since we're not dealing with that code anymore. And we can go ahead and play. If we hit, let's say the base pickup, it prints out base pickup. If we hit our mosquitoes, we see mosquitoes have drained you well. Didn't print base pickup, but character is now moving at half speed. If we hit that, playing with puppies gave you more energy and printed the name because it was running the parent, which prints. We hit the mosquitoes, we're at half speed again. Hit the mosquitoes again, we're at quarter speed. One more time, 1/8 speed, and that's about all I can take before I need to stop. Before they drained all the life and we're moving too slow to notice. All right. Any questions about how inheritance works, protection levels, or virtual and override keywords, what they're doing, kind of why it would be used, so that you can have some common functionality shared? Because keep in mind, all our pickups, we're running all this base pickup code without having to rewrite it or copy it every time we want to use it. No questions? All right. Well, that basically covers inheritance, overriding, and the part about polymorphism. The term poly just means many, and morphism meaning it can switch between them. Each one of these pickups, they are using that polymorphic type where a pickup puppies is a pickup base. It is a mono behavior. It is a behavior. So it's basically giving this one script multiple different types. Any of its parents it could technically be cast to or is considered that type. Keep in mind that doesn't go across to siblings. So like puppies and mosquitoes would be considered siblings because they're both children of our pickup base. But pickup puppies got nothing to do with mosquitoes. Same goes for parent classes. Parent pickup base is not pickup puppies or pickup mosquitoes. All right. Interfaces. Okay. Let's go ahead and add some sort of interface to this game. Let's talk about namespaces first before we get into interfaces, so that I have a little bit more time to think of something for an example of that. Namespaces. Okay. Let's talk about our namespaces. We've been using namespaces. We've seen the using statement and stuff, but let's say I wanted my own namespace. Not everything in my game needs to know about my pickups. Let's put all the pickups in their own namespace. Well, let's create a namespace. It's pretty difficult. There's a lot of different keywords. It's called namespace. And we'll create a new namespace just called pickups. And we'll put some body brackets on that. Anything we want in this namespace, we just put inside this namespace. So we've just created a new namespace called pickups. Let's start with our pickup base and do that way. Sorry, I did that in the other script, but we'll put it here, wrapping all the pickup base code in that. I'm gonna get rid of it here so we can see what's going on. Control A, Control K, Control F. So it's complaining right now. It doesn't know about pickup base. because it's inside a namespace. We can add a using statement using pickups, whatever we named our namespace. And then it knows about that type. The other way we could handle this is if it's related and should also be in the namespace, like my pickup puppies, we'll put it in the namespace as well. We just need that namespace keyword, the name of the namespace we want to put it in, and some brackets about what's inside the namespace. Anything inside the same namespace will have access to each other. I didn't have to add the using namespace or using pickups here because these are in the same namespace. So if it's got the same name, it's going to put it right in that same namespace. Any questions on the namespace? Can you have multiple namespaces in a script? Absolutely. We're technically giving access to multiple namespaces here. If we had multiple classes and things, we could put those in the namespace. Let's, for example, move mosquitoes. Let's create another one called crazy mosquitoes. Pick up crazy mosquitoes. And these crazy. And let's multiply it by 0.25, so a quarter of speed. And rather than, oh, I didn't even put them in a namespace here. We'll put we have using pickups here. Let's create another namespace for basic mosquitoes. Have that wrapped up in here. And yes, you can even nest if we had another namespace inside a namespace, you get the idea, right? Or do you want me to continue with this? That's getting kind of crazy with just the namespace inside a namespace for purposes of that. Yeah. All right, cool. And we'll just clean this up. And shove that over. All right. But yeah, you can get overly crazy with namespaces, so I would recommend wrapping up certain systems. Like I mentioned, like maybe all the pickups are in one namespace, but then ideally anything to do with the pickups, you'd also put in the pickups namespace. And don't get overly crazy with how granular you go with your namespaces, what I would put it. All right. So interfaces. Still haven't come up with anything with from the top of my head. I guess we'll go with a damage interface. We'll add damage interface to our NPCs as well as our player. So we'll take different damage stuff. And we'll have our mosquitoes rather than, oh, but I pass in player. We may change that to just a basic game object. So we may rework this code a little bit. In fact, let's do that now. Well, let's not do that now. Let's do the interface first. Let's set up an interface and take a look at what that entails and all that. All right, close out everything. I'm going to create a new script for the interface. Create C# script. I underscore damage. We'll open that up. Now, immediately, it gave us a class. Interfaces are not classes. We don't want a starter update. We don't want the keyword class here. In fact, I'm going to get rid of public as well. I want this to be an interface. We have an interface called damage. Not going to derive anything, but we'll have a function in here. Interfaces cannot have any member variables. So if we were to try and create an int and say like amount here, set it equal to 3, it's gonna complain at us. Can't contain instance fields. So no member variables. What it can contain is functions. Not an entire function, just the signature portion of a function. What do I mean by signature? Well, it can hold return types. Let's say void return type, function names, damage or take damage. How about that? Take damage. Parameters, what this function actually takes in. Let's take in a float for the amount of damage. Part of functions it cannot have is a body. We can't actually add an implementation of this function or tell it what this function does, which, as I'm reading now, apparently that will be available in version 8 of C#, but you're not supposed to have the default done. So you just put a semicolon after you've declared what the function's name is, what returns it'll have, and just that. So yes, just declaring functions, if you're familiar with that. Just the declaration, no definition or implementation. Where this interface actually gets used, other classes can implement this interface. So like I mentioned, let's add it to our player. When our player is told to take damage, have it do something. We'll change its color or something for a short period. In order for a class to implement an interface, it's right up here where you're basically telling it what parent class it's from or what its parent class is. One thing you can't do with other classes is inherit from multiple classes. So I couldn't do NPC right here. It's going to complain, can't have multiple base classes. So it can only inherit from one class, but it can have multiple interfaces. So we put that right up here, the damage interface. It's complaining, but it's not complaining about this. It's complaining because it didn't implement the interface member take damage. So we have to make sure that any interface we say we're going to implement actually defines that function. So let's look at the damage. Not that. We want, what is it? Just take damage, void return. And float in for the amount of damage. And right now it's still complaining because I didn't make it a proper type. Well, cannot implement an interface member because it is not public. So let's make sure it is public here. And that's going to complain. Sorry, I meant to make it public in the actual implementation side. public. There we go. Now it's all highlighted. Eye damage isn't complaining anymore. Control-Shift-B, compile. It's complaining about a light inside our lamp. But we'll ignore that. And we've got this function that we're running. So let's say we have this take damage function. If amount is less than 0, I'm going to say if it's greater than 0, meaning if we did take damage, we'll change the color to red. So we'll get our renderer component. From that, ask it for the material. From that, get the color, and we'll just set the color to red. Otherwise, we'll be doing the same thing, but green, because if it's less than 0 and we're telling it take damage, it's basically like saying we've healed our character. Green, not greed. Pretty close, though. All right. Now let's change our pickups so that when we hit them, they'll, well, at least for our mosquitoes, when we hit it, and we will need to change our pickups a little bit so that they work with any type. Our pickups, rather than doing that check for only players, get rid of that. I do want a do pickup, but rather than get component, we'll pass just the others game object straight in. And this should now be taking a game object, not just the player component. Game object. And our pickup mosquitoes and puppies will have to change to also accept game object, which means they'll no longer have speed. Mosquitoes will change that and change this game object. And instead, let's make puppies tell our game object to take a certain amount of damage. And we can't just call take damage. One thing we'll do is we'll actually use a message to send this function out. Not sure if you guys are aware, but you can do send message to any game object. And send message allows you to specify a function name based on string. Very similar to invoke, but on another object and not based on a time delay or anything. So the method name we're looking for is take damage. And our second parameter will be the parameter that take damage takes in. This is in puppies, so we'll do a negative damage amount. -2 damage, -20 damage, sure. Not even tracking health, so doesn't really matter too much, just positive or negative. And we'll do the same thing for mosquitoes. We'll have mosquitoes send a message to our player. or to our other game object. I'm inherently said player because I have it named P. So take damage. And parameter, we'll say it does 15 damage. Save that. All right. So our player should respond when it's taking positive or negative damage. If we let this compile, I have our puppies here. I'm going to get rid of this just basic pickup here that does nothing, but I will move my puppies over in the path of my NPC here. And if we press play, we see we are getting a warning. Send message has no receiver. So because our NPC hit it and it doesn't handle that function, Puppies was trying to send that message to nothing. But if our player was to hit it, if I press play and I hit it, boom, hey, we got green. When we hit this, it's going to turn red. Let's go ahead and make sure that our NPC also handles that interface. But let's have it do something different rather than change color. Not quite sure yet. Let's have it change speed, I guess. Yeah. So our NPC, we'll go ahead and say it does handle that interface. I underscore damage. And we'll add that function. Public void take damage. Taking a float. And I said I wanted it to increase or decrease speed, so check if the damage amount was positive. Then we'll get our nav mesh agent, or what did I call it? Probably just nav. That's what I usually use. Nav. We'll set or change its speed. If it is taking damage, we'll make it go slower. Times equals 0.5. F. Otherwise, we'll double its speed. All right. Oh, internet, no. Let's go ahead and test this. I'm also going to move my mosquitoes a bit closer so they can interact with things. And we'll duplicate our puppies around so we can have a bit of a happier time. So we press play. Now, oh God, it's moving so fast. And then slows down when it hits that, whereas the player, still calling the same function, but our pickups now know, they don't know specific types. They're sending just a generic message saying, hey, call this function you have named take damage. And anything we add that we say implements this interface can now handle that take damage function. It would just need to know about this. It wouldn't need to know about the specific type that we're using, because it doesn't know about player here at all. Puppies doesn't know about player, but it's still able to call those specific functions right off of those other classes without knowing their specific types. So yes and no. Interfaces are typically like common interactions. If you have like an interactable item or an interactive interface, and you can just have some sort of a, let's say you're doing a sphere cast every time you press space outside in front of your character. And all it does is say, I'm going to send a message saying interact with this object. And whatever implements that interface and actually handles the interact function would actually run their interact code. But if you're running up against a wall and shooting a message saying interact with it, it just gets ignored. But yes, it's a quick way to call a generic function name across many different types of objects, allowing the object that's calling it to just go through that interface versus knowing or having to cast down or having to get the specific component it needs to interact with. It can just go through that interface. Definitely. So that pretty much wraps it up for today. Were there any questions about any of the stuff that we went over today, or? You guys should have seen all this in Unreal, but probably have had limited exposure to it in Unity, and the Unreal stuff was probably a little bit high level for you at the times, but hopefully it's all making more sense than the first time you saw it. Definitely. One thing I would recommend is just continue playing around. So, oh, it's always a hate or love relationship with visual scripting for sure. All right. Well, I'll go ahead and end the recording here.